I'm in chapter 17 of the text, and the chapter is called Solving Linear Equations. Linear meaning there's no x to the power 2, x to the power 3, or any other powers. So a classic might be this one from 17b, 5z plus 3z, plus 11 equals 12. I would expect everyone in this class to be able to solve this equation, but there is some practice on it, and the lesson is dedicated just to tidy up and brush up on our solving skills for this lesson. Some might need to start on 17a, and I would guess most of us will be studying on 17b, called More Advanced Linear Equations. They're not that advanced, to be honest. This one, 5z plus 3 more is 8z. I'm straight away going to take away 11 from both sides, giving me 1 on the right hand side. And then my answer is 1/8. Divide both sides by 8. Sometimes you might be asked to expand first, like on this question here. 3, no, do a harder one. 5, 2t plus 3 equals 2t plus 4. So you might think this one's more difficult because there are some t's on both sides of the equation. The methodology is to collect the t's together on one side of the equation. Doesn't matter what side. Usually I collect on the side where there's the most to start with. I can see that when I multiply the 5 out I get 10t on the left. There's going to be more on the left, so I'll collect the t's on the left, plus 15, 5 times 3, equals still 2t plus 4. Right, collecting t's, so take away 2 from both sides of the equation. 10 minus 2t, 10t minus 2t is 8t. I've still got the plus 15, and I've still got the plus 4. I'm now going to take away 15 from both sides to try and move everything away from the t. 4 take away 15 is minus 11. And my last step will be to divide by 8. Answer, both sides of the equation. Answer, minus 11 over 8. Make sure your writing's better than mine. That doesn't look like minus 11 to me, but it's a bit difficult writing with your finger. Sometimes you get equations with fractions in them. When we get a fraction, we always multiply by the denominators to undo that fraction. So in the first instance, I would multiply the first fraction by 3 to undo divide by 3. So the first term now looks like that. X, because 3 divided by 3 is 1. And then if you do times by 3, you've got to do it to every term. So the next equation is going to look like this, 3x over 4. And you have to do it to the right hand side of the equation to keep the thing in balance. So the right hand side now looks like that, 2 times 3. And then again, I'm undoing fractions, so multiply by the denominator, both sides. I'm now left with each term, 4x plus 3x equals 24. Simple. 7x equals 24. X equals 24 over 7. Leave it as a fraction. Here's another equation. Looks complicated, it's not. Multiply by the denominator, which in this case is 2a plus 5. So both sides multiply by 2a plus 5. It's my operation. Leaves 3a minus 1 on the left equals 2a plus 5. Now it's half of that. You can either write it all over 2 or you could put it in brackets and still have the times by half. Maybe I'll do it like that this time. Again, I don't like fractions on the right, so I might actually multiply both sides by 2 to get rid of the 2 on the bottom. So times both sides by 2. Left hand side now reads 2 3a minus 1, and the right hand side is just 2a plus 5. Remember the method when you've got the term on both sides of the equation, you've got to collect them together on the same side. So I'm going to try and get rid of this set of brackets by expanding the 2 out. 6a minus 2, 2a plus 5, and now I'm going to take away 2a from the right and the left, so I'm left with 4a minus 2 on the left equals plus 5. Add 2 to both sides, left with 4a equals 7. Last step.
Bye.